Students, हम लोगों ने learning switches के केस में we went through an issue and that issue was of the loops that are created. हमने ये पढ़ा था कि जहाँ पे भी we have got one or more broadcast LANs connected to each other by using more than one switches, redundant switches, we end up with an issue where we have got a loop problem. The LANs, they keep on sending their frames, and the switches, because those switches are using the learning process, they keep on sending those frames in the broadcast method, outside all of their the output ports, and therefore we end up with a loop problem. Students, the solution to that problem is the spanning tree algorithm. Students, the spanning tree in graph theory, it means a graph in which there are no loops. Students, in the case of switched LAN or in our data communication language, this means that we create a topology in which a LAN can be reached from any other LAN by using only one single path. So although you have got redundancy in there, your physical topology will have redundant switches, but you actually create a logical topology using the spanning tree algorithm, and in that logical topology, what you will have is you will have only one path available from one local area network to the other local area network. So there will be no loops. Students, how we accomplish this is we accomplish this by allocating a particular cost vector or particular cost to every single link that we have in our network. Students, slide pe chalenge and I'll try to explain this spanning tree algorithm a little further. So students, it actually, as I told you, we have got multiple switches. In this case, you have got 5 different switches, and you have got 4 different LANs. Students, in this case, I am representing the local area networks also by using a particular node. You can also represent this local area network by a cloud or just by a link that connects the 2 switches. Students, in this particular case, what we do is, as I told you, the first step is that we allocate a particular cost vector. The system administrator allocates a particular cost metric to each of the links. Students, the interpretation of this cost and what this cost is going to be, it's completely up to the system admin of that particular network. You can have a particular cost metric which actually represents something in one particular network, and the same cost metric can actually represent something completely different. So each network can use or create its own specific cost metrics. So the point is that by using that cost metric, we try to get to the minimum hop. If we need to get from one single primary system to all the other systems, we need to have the minimum set of hops that we need to know from. So students, in this case, the hop count that we are using, it's normally 1 from a switch to the LAN, and it's a 0 in the reverse direction. So students, what we do is if we assume that this switch S1 is our primary switch, then what we are going to use is that the hop count is 1 from this switch to the LAN. So for example, this switch to the LAN, it's going to be 1, and the LAN back to the switch is going to be 0. So we have chosen 1 and 0 as our cost vectors for this particular topology that we have. Students, what we do is we represent this in the graph format by using spanning tree. जैसा मैंने आपको बताया था, because S1 we need to find out the overall distance from one particular switch to all the other the switches, in other words the shortest path. So in order to do that, the first step is that we allocate these cost vectors. So हर switch से LAN की तरफ we allocate a cost vector or a metric of 1. From the LAN back to the switch, we allocate a cost vector of 0. Similarly, LAN 1 to switch, because we are going from a LAN to the switch, it's a 0. Switch back to the LAN, it's a 1, and so on. So it's एक ही topology है. If you concentrate switch to the LAN is a 1, and LAN back to a switch is a 0. So that's how we allocate the different cost metrics in the case of spanning tree algorithm. Students, the point in this is to calculate a topology in which this spanning tree algorithm, it can find the shortest path. The shortest path is a path which has got the shortest cost. given the metrics that you have defined. It has got the shortest cost from the root switch to every other switch in the LAN. So in this case, we have got a primary or a root switch, which we have chosen to be our switch S1. Now students, we can find out this shortest path by examining the total cost from this root switch S1 to all the different destinations. Students, आप गौर कीजिएगा, मैं आपको I will scroll between these two slides, don't get confused. In this one, as you can see, the shortest path from S1 to LAN 1 is 1. So we write 1 here. We'll go to the next slide now, part C. So the shortest path from your root switch, your LAN 1, is given by 1. Students, shortest path from your root switch, which is S1 to LAN 3, for example, is this particular 1 plus 0 plus 1. So the shortest path from S1 to LAN 3 via LAN 1 and switch 2 has got a total cost of 2. This one plus this 0 plus this one. So students, you have got a 2 here. And students, in this particular case, what we have done is we have actually found the shortest path in the spanning tree algorithm for each of the switches by using our root switch technology. Students, गौर कीजिएगा कि this topology using the spanning tree is completely different from your physical topology. You have got some blocking links in there, and you have got some forwarding links in there. For example, this particular link that we had out here, this is your blocking link. The spanning tree, because of the shortest path algorithm, has eliminated this particular link. We have got another blocking link out here, and we have got a blocking link out here. So the links which are eliminated as a result of the spanning tree algorithm from our actual system are called blocking links, and the rest of the links which are actually forwarding the data, they are called the forwarding links. So we have got a forwarding link, a forwarding link, a forwarding link, and the rest of the links are blocking links. Students, that is what I represent using this particular slide. Your root switch and port 2 and 3 of this bridge S3, they are the blocking ports. Port 2 and 3, they are the blocking ports. If we allow those ports to forward the data as well, we will end up with the loop problem again. So they are designated as the blocking ports. Similarly, switch 5 ke case mein port 1 is blocking, and then you've got all the other ports as the forwarding ports in the case of spanning tree algorithm.